Hello, welcome to homework help for 6.7, logarithmic equations. Today we're going to do problems from 1 through 4 from page 36 in the handbook. So before we begin, let's do a couple of quick exercises. I want you to take a minute, write down these log properties into your notes. These are properties you really should memorize. We explain in class why they are so, but it's really important to just memorize them as well. So here's what you need to know. Log of a negative number is always undefined or does not exist. It doesn't matter what your base is. Your base could be 10, for example. Your base could be e, so that means that this could be natural log also. Natural log of a negative number also does not exist. It could be log of base 5. Anytime there's a negative number in here, answer is does not exist. Also, log of 0 with any base does not exist. So I'm going to put little base a's to represent any base. And then finally, log of 1 is always 0. Now, this one's pretty easy to explain. If I were to go from this log form into exponential form, we'd bring down the 1 and set it equal to, well, anything to the 0 is 1. So we see that this is true. So I would like you to please memorize these, and now let's practice them over on the right. If you study them for a minute, then the problems on the right should each take like less than 5 seconds. All right, let's do our first one. First example says log base 3 of negative 3. Well, since I'm taking the log of a negative, I know this does not exist, and that's from rule 1. Next example, log base 5 of 0. So really the question is if I set this equal to x to solve, 5 to the what power gives us 0? Well, again, this is from rule 2 here on the left. Log of 0 is always does not exist. And if you try different exponents, like 5 to the negative 1, you'll get 1/5. If you take 5 to the 0 power, you'll get 1. If you do 5 to the 1, you'll get 5. There's no exponent that will give us an answer of 0. So this is simply not true. The exponent does not exist. Next, natural log of 1. This is actually from rule number 3. Remember, it's log with any base. This is just a log with base e. So if I were to evaluate this, going from log to exponential form, I would say, hey, e to the which power gives me 1? Well, the only power is 0. E to the 0 gives me 1, and that's why this rule holds. The answer would be 0. But again, if you have memorized these on the left, that takes less than 5 seconds because you recognize log of 1 is always 0. Okay, these last two are a little more challenging, which is why I put red stars next to them. So if I need to evaluate this log, notice we're missing a base. Our base is 10. So the question we need to ask ourselves is, what does this evaluate to? You could set it equal to x, for example. So 10 to the which power gives us 1 over 10. If you remember your negative exponent rules, you'll recall that the answer is negative 1. 10 to the negative 1 is really 1/10. So our answer here is negative 1. Okay, the last one is also a little more challenging. Write in your invisible base. That's e. Let's set it equal to x so we can ask ourselves, e to the which power will give us e squared? Well, the only exponent that gives us e squared is going to be x equal to 2. And so you see that our answer here is actually just 2. So these are a quick review of how to evaluate logarithms. Let's jump into our homework now. Problem number 1b says log of negative 3. If you type this into a calculator, guess what you're going to get? You're going to get undefined or does not exist. Why? Well, it's back to rule 1. You can't take log of a negative number. So log of negative 3 does not exist. Our answer Undefined or does not exist. Just by knowing the rules. Okay, B now. B has a little more work to do, right? So if I want to solve for x, this doesn't look like any of the rules that we have, right? We don't have log of 0. We don't have log of a negative number. What we have to do here is ask ourselves, what form am I in? Well, I'm right now in log form. That means that we should go to exponential form. So to do that, we'll cross out the log, bring down the x, and set it equal to, our base is 25 and our power is 1/2. So it's 25 to the 1/2 power. So x is equal to 25 to the 1/2, but that's not simplified all the way. See if you recall how to rewrite power of 1/2 as a root. This is really x equals the square root of 25. And the square root of 25 is 5. So that's our answer here. All right, let's go to problem number 2. All right, problem number 2 looks a little different from the last ones we did, and here's the big difference. Notice that we have logs on both sides of our equal sign. Okay, so let's do some quick notes on how to deal with these new types of problems. Okay. So if you have logs on both sides, which is what we're dealing with right now in problem 2D, we have logs on both sides. This is just a property, a rule that you can write down in your notes. If log base b of x equals log base b of y, so what's true is that we have logs on both sides and they have the same base. Well, if that's true, then x has to equal y. We basically can kind of cross out the logs and just set the insides equal to each other. So we get x equals y. So essentially, if you have logs on both sides and there's just a single log on the left, a single log on the right, we're just going to set the insides equal to each other. However, previously we had logs only on one side. So it looked, here's my only log, it's on the left. And on the right, you could have something like a number, like 2 or 5, or even x. But if you have a log on only one side, then you're going to have to solve this by going from log form into exponential form. So you're going to bring down the a and set it equal to b to the x power. Okay, so please keep in mind the two different types of log problems. One with logs on both sides, where you cross out the log and set your insides equal. And then one with log on just one side, in which you go from log form to exponential form. So let's have a look at a quick example of each. So on the left here, I have an example of logs on both sides of the equal sign, and they have the same base. So that means that 2x plus 1 must equal 2. I'm going to simply cross out my logs and set my insides equal. Then I can finish the problem by getting x by itself. And x is going to equal 1/2, all right? It's not so important what the answer is really. I just want you to remember the process, okay? So cross out the logs on both sides and then set the insides equal. Look at the difference between the left side and the right side though. On the right, we only have one log and it's on the left. So we can't solve this by crossing out the logs because there's nothing to cross out on the right. So you have to go from log form into exponential form and solve it the old way. So if I'm in log form and I want to go to exponential, cross out your log, bring down the 2x plus 1, and set it equal to 3 squared. That's the key difference here. On the left side, we simply cross out the logs, set the insides equal. On the right side, we go into exponential form, and then we would solve it like this, minusing the 1, and we get x equals 4 after dividing both sides by 2. Again, the answers are not so important. just a demonstration of different types of log problems. So, if you didn't already, please write down these two notes. Now let's go to problem number 2. Which kind of approach will we use here? Well, since we have logs on both sides, and they're both the same base, we can cross them out and just set our insides equal to each other. We get x squared minus 3x equals 4. Now we want to solve for x, and we have a quadratic, x squared. So recall, to solve a quadratic equation, you always move all terms to the same side and set them equal to 0 so we can then factor. So that's our first thing, and then factoring is our second thing. Well, let's get everything to the same side then. I'm going to minus 4 on both sides, and I'll have x squared minus 3x minus 4 equal to 0. And now I'm ready. I finished step 1. Now I'm ready to factor. So this would factor into, so try it yourself, of course, first. This is going to factor into x minus 4 and x plus 1. Meaning that my two answers are actually x equals 4 and x equals negative 1. So this is nice. We got two answers here, but there's one thing we have to check. In logarithms, remember how we said you can't take log of a negative number? That does not exist. Well, that means that we could have extraneous solutions. So we need to check to make sure that these are both valid. How will we check that? Well, we need to plug them back into the original and make sure that when we plug these numbers back in, we don't get a negative number inside. So check it out. I'm going to rewrite it and plug in the numbers. You must always check for extraneous solutions when you're dealing with log equations. Let me rewrite this. I have log base 2. X squared minus 3x equals log base 2 of 4. So I'm going to check right now if x equals 4 is okay. So if I plug in 4 here, I get 4 squared minus 3 times 4. 4 squared is 16. 3 times 4 is 12. So 16 minus 12 is 4. Well, remember, we're taking a log of that number, and log of 4 is okay. That exists. If we had done the work, let's say, and gotten log of like negative 4, then we would say, ooh, that's extraneous because you can't take log of a negative. But in this case, it worked out. Okay. Let's try plugging in negative 1 now. It's lunchtime, by the way, in case you didn't notice. Okay, so now let's plug in negative 1. So we have log base 2. If we plug in negative 1 here, I get negative 1 squared minus 3 times negative 1. I need to make sure that this doesn't turn into a negative number or 0. So that would become log base 2 of, well, negative 1 squared is positive 1. And then negative 3 times negative 1 is plus 3. So again, I have log base 2 of a positive number, so that checks out. That means all of our solutions here are actually okay. So we have two answers then. Our answers are x equals 4 and x equals negative 1, and we had no extraneous solutions. Let's go to problem number 3 now. Problem number 3. Which type is this? Is this the type where we can cross out the logs on both sides? Or is this the type where we have to go into a different form, into exponential form?
Rebecca Finones and Caleb Perkins, please report to the attendance office.
This would be the type of problem where we have to go from log to exponential because we have a log only on one side. So to solve this, we're going to have to convert forms. So let's cross out the natural log and write in our invisible base so that we can convert to exponential form. Okay, we're going to bring down the 3x minus 5. Bring it down. and set it equal to our base, which is e to the power of 0. Okay, let's simplify the right side. What's anything to the power of 0? Well, an e to the power of 0, or anything to the power of 0, is always 1. And now we can solve for x pretty easily by adding 5. Get 3x equals 6. And then let's divide by 3. We'll get x equal to 2. But before we circle our answer and feel okay with that, we have to check. We have to check for extraneous solutions. So we got to take that 2, plug it way back in here into our original expression, and make sure that we don't end up taking natural log of 0 or natural log of a negative number, because these does not exist. These would give us extraneous answers. So let's plug it in. I have natural log of 3 times. So instead of x, I'm going to write 2 minus 5. Well, 3 times 2 is 6, and 6 minus 5 is 1. So I'd be taking natural log of 1. Hey, that's okay. I can take natural log of 1, and in fact, if I did, the answer would be 0, if you remember your rules from before. So we have no extraneous solutions here. This is valid. Let's do one final problem. Problem number 4. Okay. So it says if log base 3 of x minus 1 equals negative 1, then x equals negative 2. True or false? We can try just by, let's say, plugging in the answer. So if x equals negative 2, I'm going to plug that in. I've got log base 3 of negative 2 minus 1. So I replace the x with the negative 2. And that's supposed to equal negative 1. Well, we need to see if that's true or false. So let's put a question mark. Let's simplify. That's log base 3 of negative 2 minus 1 is negative 3 equal to negative 1. Wait a second. Slow down there. What is the problem that we've just encountered? Psst, look at the left side. Log of a negative number does not exist. So it can't equal negative 1. This is impossible. So I know this is false. Just because I ended up taking log of a negative, which we know is not allowed. Let me show you another way that you could solve this problem. How about we go from log form to exponential form? I'm going to rewrite this. Let's see what x really should equal. We know it's not supposed to be negative 2 because it didn't work out. But let's see if we can figure it out another way. Okay, so let's solve. I'm in log form. I need to go to exponential form. So cross out the log, bring down the x minus 1, and set it equal to 3 to the negative 1. So if x minus 1 equals 3 to the negative 1, that means I could rewrite this as 1 over 3. And so x, we'll get it by itself by adding 1 on both sides. So x equals 1 plus 1/3. Now, that's fine, but I want to get a nice single answer. So let's add 1 and 1/3. That means 3/3. I'm getting common denominators. Plus 1/3. So x would equal actually 4/3. This is the true right answer. And I solved that by solving the equation. But again, you could have gotten the answer false faster just by plugging it in and realizing that you cannot take log of a negative number. All right, I hope that was helpful for you, and I wish you a very good day.